in that part of the lesson, we are trying to complete our organic reactions. So we have a new type, it's called polymerization. Even in your book, it is not written like that, polymerization. In your book, it is written polymers or something. So the same thing, it is the formation of polymers. Polymers or polymerization are the same. Polymerization is the process in which we can form polymers. How can polymers are formed? What are polymers first? What are the polymers? They are large molecules. To understand the polymerization as a type of organic reaction, we must know what are the polymers. In your book, you will find that polymers are large molecules made of a small units. These small units, called monomers, join together, monomers. So, what is the difference between polymers and the monomers? Poly, it means many in English. Mer, M-E-R, it means units. So, many units. And in the other side is mono, it means one. Mer, it means one unit. The same. So, many units from one unit. So, the polymer is a large molecule which contain many units. Polymer from just one unit. So it is my unit is called monomer and the large molecule is called polymer. So polymers are large molecules made of many small molecules which are called monomers. Now we are going to discuss another concept called copolymer. Copolymer. What is the copolymer? Copolymer. You know that polymer is a large molecule, as we said, from small units which are called monomer, as we said before. But what's meant by co? Co in English, it means two things or more combined with each other, like cooperation between two persons. Also, copolymer, it means two or more different units combined. Is made up of two or more different units, or monomers. I can say monomers now. So therefore, we must highlight different, because co, it means different polymers combined with each other. So I have polymerization, I have polymer, I have monomer, I have copolymer from combination of two or more different units. Now we will study the addition reaction produce addition polymers. Now we will connect between two types, between the additions and the polymerization. You must know that polymerization is a type of addition. How can that occur? Polymerization is a type of addition, special type. I consider it like that. It is not in the books, but I consider it is a type. How can that occur? If I have ethene, and you know ethene is C H2 double bond CH2. That's my ethene. That molecule, if I have N of that ethene, and I add these molecules to each other in a polymerization reaction or addition of the same molecules to each other with certain conditions like pressure and heat. So I can break down the double bond and add the molecules to each other. So I can add ethene to ethene to ethene to ethene. If I have N of these ethenes, So they can be added to each other, and I can break the bond like that. I can break the bond. And there is no limit for ethene, which added, so I write N here. So it is called, that is ethene, and that one is called polyethene. Why polyethene? It is not ethane here because its origin is ethene. So it is called polyethene. I break down the bond and add the molecules to each other. So from ethene, I can get polyethene like that. The condensation reactions often make polymers. Also, condensation can make polymers, which, like polyethene, which is called polyethylene. Sometimes it's called polyethylene. We have also LDPE and CPE and HDPE. And these molecules are called properties of different from ethene, like LDPE, which is called LDPE, low density polyethylene or ethene. Low density it is abbreviation LDPE. And HDPE is high density polyethylene, and so on. And CPE is cross links. According to the shape in your book, in page 704, you can find these shapes or this figure highlighted in many types of plastics, as you see in the page 704. There are types of polyethene or polyethylene according to the bonds or brand, or according to the strength or density, low density and high density polyethene, and CPE is linked polyethene with a certain bond, sulfur or any other atom. Now we will study the polyamides and polyesters. What about the poly? The last thing is the polyamides and polyesters. What is the difference between them? If I have hexane diamine, I have 6 carbon, and there are 6 carbon and 2 hydrogen, like that, 2 hydrogen. 6 and all that is hydrogen, and diamine, NH. That's the hexane diamine. It's called hexane diamine. Hexane diamine. And I have also adipic acid, which contain 6. The plus we add 6 double bond OH. That's adipic acid, and contain C2, 3, 4, and 6 double bond O and OH. That's called adipic acid. Adipic acid. If we add these to each other, that's a condensation. Why condensation, mister? Because we can remove 1 molecule of water, as we said before. If we add that compound to that, so we can get our product here by removing 1 hydrogen with 1 hydroxide, so you form 1 molecule of water. So my product will be, in the next slide, my product will be N and H, C double bond O. I have here 1, 2, 3, 4 carbon, okay, and C double bond O, OH is the rest of the acid. And sorry, here is not, it is just single bond, but here it's just single bond here. So here, and we can complete the other side. by 6 carbon atoms also, CH2, 2, 3, 4, 5, 6, that's the 6 carbon, and NH. So that's my result, molecule. That bond is called peptide bond, and the compound is called nylon 6,6. Nylon 6,6. That's all these slashes or dashes are hydrogen, as you know. All these are hydrogen, and it has no limit. It is N of it. It is a condensation reaction. It is a type of polymerization reaction. It is a polymerization, but with a condensation, since we removed before molecule of H2O from it. And it is called the nylon, that product is called nylon 6,6. Why 6,6? Because I have 6 carbon here from hexane diamine and 6 carbon here from adipic acid, so it is called nylon 6,6, and it is a very known example for the condensation reaction. And also it is a type of polymerization or polyamide.